Okay, question number 6. A jet is coming in for landing. It's currently 25,000 feet in the air, and the landing strip is 45,000 feet directly ahead. Okay, all right, so I can't draw airplanes, but anyway, here's my airplane. I don't know what an airplane looks like, but anyway, it's got wings. Okay, there's my airplane. Okay, and it's currently 25,000 feet in the air, so I could say that this is 25,000 feet. Okay, and a landing strip is 45,000 feet directly ahead. It's not a diagonal measurement. This is going to be a horizontal measurement, and it's definitely not drawn to scale. But say this is 45,000 feet. Okay, all right, so we're looking at this kind of a triangle. And there's a right angle right here. Okay, a jet is coming in for landing. It's currently 25,000 feet in the air, and the landing strip is 45,000 feet directly ahead. In order to safely land, the plane needs to come in at no more than 30 degrees angle of depression. Okay, an angle of depression. Some of you may know what this is, some of you may not. Okay, the pilot is here. If he looks straight ahead, that's where you measure an angle of depression from. An angle of depression is measured from the horizontal going downwards. Depression means to go down or to look down. So here we're looking to find out what this angle is here. Okay, we don't know what it is. Okay, we don't know what this is, but we do know that it needs to be no more than 30. We cannot say it's 30. We don't know it's 30. Okay, so the first thing we're going to notice is we're using trigonometry. Okay, all right, let's do method 1. There's 2 ways of doing this, okay? You don't have to do both ways, but anyway, here we go. Method 1, if we say that, actually I'm going to call, for this question, I'm going to say that this is theta. We'll use this angle here, we'll figure out this one afterwards, okay? So this would make that my opposite side, and this side would be my adjacent side. Here's my angle. Across from the angle is opposite. Next to the angle is adjacent because this is clearly the hypotenuse. Okay? Replace the values. The opposite is 45,000 and the adjacent is 25,000. Make sure you realize OA, you look up here, the last 2 letters. Here's an O, here's an A, we're using tangent, and that's why we have tangent of theta is opposite over adjacent. Okay? And then to find the angle, inverse function, inverse tan of this ratio, okay, will give me the angle, and the angle 61 degrees. Now, we're not asking for that angle to be less than 30 or no more than 30. We're asking for this one, okay? These 2 angles together form a right angle, okay? Okay, so if we do 90 minus that angle, that's going to give us 29 degrees. 90 minus 61 is 29. 29 is clearly less than 30, so we're definitely within the right measurements there. Okay? All right, method 2 is very, very similar. Okay, I could just go ahead and here's my airplane. I don't know what happens at the back of an airplane, but anyway, there's my airplane. Once again, same measurements, 25,000 this way, 45,000 that way. Okay, the only difference is, okay, in this question here, we got this answer. We found out what theta was, and we subtracted from 90. I'm going to do something different now, okay? I'm going to make this into a rectangle, okay, just by drawing 2 dotted lines. This line is the same length as that, so this is 45,000. And 25,000 here, 25,000 there. And I'm going to find theta directly because I'm going to use the triangle up here. Okay, once again, we've got opposite. This time my 25,000 is my opposite side because the angle is here. Opposite, and this one becomes the adjacent. Notice how they've switched places. Okay, so once again, still tangent. Plug in the values is 25,000 over 45,000 if you use this method. And then inverse function gives you the angle, And there it is, 29. You don't need to subtract it from 90 because you're finding the angle of depression directly. And the answer once again is yes, because 29 is less than 30.